Welcome. My name is Laurent Sansonetti. I work for Apple in the operating system team, where I work on many things, especially on the scripting technologies and on the Ruby support. Louder, please. Okay. And this is the agenda for this session. And I will start with a quick overview of what's new on Leopard. Then we will see, we study a bit more Cocoa development in general, and then I will speak about our plans for the futures, especially when it comes to Ruby and macOS 10. And then there will be some questions and answers. So if we look at Ruby on macOS 10. Ruby has been present on macOS 10 since 10.2. The first version that entered on macOS 10 was Ruby 1.6.7, and it means that since the very beginning of macOS 10, it was possible to write Ruby scripts and make sure that they are portable on the system. And on the latest version that was released a few days ago, we released some new stuff with Leopard. And I would like to know if anybody are using Leopard here? It's good. So there are many people. Just straight like that? Yeah, it's better. It's better. And how many people are enjoying the experience so far? Oh, that's okay. That's okay. And so, what's new on Leopard when it comes to Ruby? We have a better distribution. We have Ruby is now delivered as a framework. It's great because we can, in the future, ship the different version of Ruby inside the same package. And we are also delivering Ruby games with a few games by default. And it's great because if you want to upgrade your system, you don't have to wait for Apple to provide software updates. You can just do gem upgrade, and you will get the latest games available. And we have a better development environment. It means that now Apple is supporting Cocoa programming in Ruby. And we also offer DTrace support. And in this session, I'm going to focus on better development environment. I'm not going to talk about the Ruby distribution because it's not very interesting. And let's start with Ruby Cocoa. Ruby Cocoa is a bridge from Ruby to Objective-C. And it's not Cocoa specific because you can access every Objective-C code using Ruby Cocoa. And it's not only Objective-C also because you can bridge C APIs using Ruby Cocoa. And I'm going to discuss this more after. Ruby Cocoa is not a young project. It was created in 2001 by Fujimoto Izakuni, which is not here, unfortunately. And I'm now the official maintainer of Ruby Cocoa. And during a few years, it was more or less dead. And now the project is now very active. We have 6 or 7 active developers. And it's used by a few projects, which are both free and commercial. And the big news is that it's now included and supported on Leopard. It means that you can write Ruby Cocoa application on Leopard, and Apple is providing support for it, and will make sure that there will not be any compatibility issue. So it means that your application will be supported on new version of macOS. It's a mix of both Objective-C and Ruby Cocoa. And so it's a commercial application. It's called Backpack. It's a client for the 7 Seniors Backpack web application. And the nice thing about that is that it's delivered. The Ruby Cocoa source files are encrypted and obfuscated with the application. So it means that you can use Ruby Cocoa to write proprietary and commercial applications. On the second time, there is a nice example called Limchat, or Limechat, I don't know how to pronounce it. Limechat is very popular in Japan. I'm not sure if there are some Japanese here. And it seems that the Windows version of Limechat is the most popular IRC client in Japan. And the author decided to port it to to the Mac using RubyCocoa. And it's now very usable. You can download it, and it works fine on Laurent. And it's free, of course. It's on the GPL license. And a nice thing about Laurent server is that the podcast producer feature is written using Rails and RubyCocoa. It's the first Apple product that actually uses Ruby. So it's great news for Apple and the Ruby community, perhaps. And I'm not going to discuss the Laurent server because it has a very complex architecture. But the idea is that you have a desktop client, and then on the server you enable people to start recording podcasts. And everything is, the server side is written using Ruby on Rails, and the server is launching some small utility tools that are based on RubyCocoa. And how does RubyCocoa work exactly? So it's a bridge, and since it's a bridge, it has to create. Since it's a bridge, it has to create proxies. So there are proxy classes that forward messages from one runtime to the other runtime. So if you are in Ruby and want to access for the first time an Objective-C class, RubyCocoa is going to create a proxy class for it, and then every message that you will send to that class will be forwarded to the Objective-C instance. And it's very dynamic. By default, the proxy has an empty method list, and we are using method missing on the Ruby side for that. But since method missing has a cost, we automatically define the Ruby method, the proxy, so that the second call will be direct. And it's very good for performances. And as you can imagine, parameters are converted from Ruby to Objective-C. The return value is converted from Objective-C to Ruby. And we also convert exceptions. So if you call an Objective-C method that raises an exception, we will catch it and convert it as a Ruby exception and call it back to the Ruby runtime. And the last point is that Objective-C, RubyCocoa maintains Objective-C objects for you. What does that mean? It means that Cocoa can be used in two modes. There is the old mode, which is using a return count mechanism. Every time you create an object, you have to release it. And it's a bit painful because in Ruby we have a garbage collector, so that's great. And in Objective-C 2.0, you can now use garbage collection, but we don't support it yet. But in that way, if you use RubyCocoa, you never have to retain or release your objects. RubyCocoa is smart enough to, after the questions, RubyCocoa is smart enough to release the objects when they are not necessary anymore. The message convention is quite simple. The idea is that you substitute every semicolon with an underscore in the selector. And to give you an example, there is a very small code snippet of Objective-C, and there is the equivalent in Ruby. And the third line in the Objective-C snippet, desolve to point fraction, will be translated in Ruby as desolve to point underscore fraction. It's not very nice, but we can live with that. And in Ruby, you don't have to release the image object because it will be unlocked by RubyCocoa. And you can see that there are some convenience facilities in Ruby. You don't have to call set background color. We can call background color equal, and RubyCocoa will redirect the call to the set background color method. And that's more or less. And so I'm going to show you some demos about RubyCocoa. Okay, so for the first demo, I'm going to create a very simple RubyCocoa application using Xcode and Interface Builder. So I start by launching Xcode. And I'm going to create a new project. And here, as you can see on the port, you can create a RubyCocoa project, but also CocoaPython project. We support both languages. And I'm going to create a very simple RubyCocoa application. and I'm going to name it Hello Ruby. And so Xcode just generated a very simple project, which is empty by default, and I can build and run. And it's only that, so it's an empty window. So it's not very interesting, and we will start by editing the user interface. Oops, where's my window? This is my window. And I'm going to put a text field on it. And a button. Oh. And I'm going to call it speech. There we go. So the purpose of this application will be that you write text in the text field, and then you click speech, and the system is going to speech the text you wrote. And now we have to write the Ruby code that is associated with the user interface. And we go back to Xcode, and I create a new file. And I go down, 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 and I will create a Ruby NSObject subclass. And I will name it my control. There we go. And I can just save it, for example. And the nice thing about Xcode and Interface Builder in Leopard is that they have Ruby support by default. So here I created an NSObject subclass in Ruby. If I go back in Interface Builder, I instantiate a new NSObject. Here I can select my controller, which is great because it shows that Interface Builder is aware that I created a new subclass in Xcode. If I go back in Xcode and if I create an outlet called text field and an action called speech, I save. If I go back, but outlet means if you're not familiar with Docker, an outlet is a pointer to a user interface element, and an action is actually what will be called on a certain event. So I save my file, and now I go back to Interface Builder, and boom, they just appear. That's great. And I'm now able to connect them. And there we go. Now the user interface is complete. I just need to write the logic of my small application. And include OS10. Oops. And because I'm a very bad demo guy, I have a cheat window. There we go. So the code is very simple. We just use the Coco NSSpeech synthesizer class to get the default voice, and then just say to the system, start speaking string. And we just pass the string value of the text field outlet. I save and start and save. So I'm going to implement the volume.
Hello.
It's working. And
Apple is good.
So I have a second small demo, and can you read the code? Okay. Okay. So this is Coco REPL, which is a sample application which is delivered with Ruby Coco, and it's an interactive editor. The idea is that you write Ruby expressions and then you can interpret them at runtime. And for example, if I write 1 plus 2 plus 3, I interpret 8, 6. And I can start by including the OS6 module and by creating a new NS window object and show it. Boom. The window object is here. And I can change the title. And now I can do some very nice stuff like recurring parse composer, setting a content view, allocating a new Quartz composer view and setting as the content view of the window, and loading a composition, and then start rendering. Oh. And you can also use Ruby threads with Ruby Coco code. It works very well now. It used to have lots of problems in the past, but we managed to solve all the problems. Normally it should be great now. It's problematic because the Ruby threads in Ruby 1.8 are not native threads, and we had to patch the interpreter to do some very bad things. But fortunately, with Ruby 1.9, everything should disappear. And you can start a new thread that just set the frame interactively. Oops. Oh, ah. Or changing the alpha value of the window. And if I print the thread list, you can see that I have 2 threads that are running here, and I can start both threads at the same time and print the thread list. And you can see here that I have 3 threads, so the main one and 2 threads that were started. And it's working. The nice thing is about Ruby Coco REPL, this program, is the interactive editor, so you can prototype things in this specific view and then copy-paste the result in your application. You don't have to build, run, stop, build, run, stop. You can easily prototype stuff there. And it stops rendering, remove from superview, and close. And I have a thank you. I have a last demo about Ruby Coco, and so it's about Ruby Inject. Ruby Inject is a package that I wrote a few weeks ago, and the idea is to dynamically inject the Ruby interpreter on any process in the system. It's using the Mac Inject API. Of course, you need to be root to do that. You can do that as a normal person. And so what it does is that it's going to use Mac Inject to start a new thread on a given process. It's going to initialize the Ruby interpreter, then start DIRB, which is the distributed object system. And once DIRB started, it's going to use Bonjour to advertise the DIRB URI. And the client side is going to wait for in Bonjour. And when it gets the DIRB URI, it starts IRB, and you can manipulate the application. I'm going to show you a demo because it's very nice when it's used with Ruby Coco. So I will start TextEdit. Okay, so this is TextEdit as you know. And first, we have to get the PID of TextEdit. And this is this one. Inject. Okay. It takes a few seconds. No, here we go. So we are connected to TextEdit. And I can, for example, do 1 plus 2 plus 2, and I get 6. The problem is that we don't get a fixed num, we get a string. It's a problem with DIRB. But now I can require RubyCocoa on TextEdit. So now RubyCocoa is loaded on TextEdit, and I can include the time module and get an instance on the NS application, which is the current application, and it's that TextEdit. So if I ask for the window, you will see that I have a single window. If in TextEdit I open a new window, I write the same command, I have 2 windows now. And I can just close the window I just opened it. I don't need it. And yeah. And I can ask for the title of this window. It's untitled. And I can change the title. I can get the content view of this window. It's a NS view, and I can get the subviews. So it's a scrolling view. No, because it's based on RubyCocoa. Yeah, the bridge is dynamic, but we have a method in RubyCocoa to show the ObjectiveC. Yeah.
Can you get to the controllers?
Yeah, everything. And this is the preview. So I'm just browsing inside the view hierarchy of TextEdit, and this is the text view. This view. This view.
So what's the Cocoa programming book you recommend?
Just a sec. I can ask for the string, and the string is empty, and I can set to hello. And stop. So you can actually communicate with everything. And I have a better example. And so it's also based on TextEdit, but yeah, it has a new NS button, and I can write a Ruby expression and evaluate it. So and it sets the reply. This is the result of the Ruby expression, of course. Yeah.
Okay, I don't care about input manager anymore.
Okay.
Why write your own app?
So
Someone else's.
the nice thing about the nice thing about Ruby Inject is that you can use RubyCocoa as a reverse engineering tool to see what is to get more information about the given application, but you can also extend any Cocoa application by providing custom controls or removing views or doing what you want. There are things that don't work because Ruby is not thread safe, so we need to call Ruby on the different threads and route all the calls from one thread to the other. So it's working nice for those little examples, but if you need to do some complicated stuff, it can be problematic. And the second problem is if you want to do some drawing methods, the Cocoa drawing is not thread safe. And since we are doing the drawing on a different thread, it's not going to work. So, but
Can you articulate that all one more time regarding thread safety?
can I?
Totally
Can you
understand.
say it again? Hold the mic up when you talk about thread safety.
Sorry. So since Ruby 1.8 is not thread safe, we need to start it on a different thread. And every time we receive a callback from the real threads, TextEdit thread, we need to route it to the RubyCocoa threads and route it back to the. It's very problematic, and you cannot do Cocoa drawing on a different thread. It's a limitation of Cocoa, and so this is why Ruby Inject is maybe not good for every use cases. But it's just a project. And so these are the demos, and okay. this is the macOS 10 development stack. We have 4 different stacks. The Darwin stack is the very low level. It has the kernel, the libc, libsystem, launchd, etc. And it's mostly written in C, so it's 99% C APIs. There is the graphics and media, which is not very readable. The graphics and media contains all the graphical media frameworks like OpenGL or Quartz Composer, which I just showed. And these are mostly written in C and ObjectiveC. In C and ObjectiveC. We then have application frameworks, which are the frameworks that you're going to use firstly when writing a Cocoa application, like Foundation, AppKit, but also the frameworks to communicate with Apple applications, like Instant Message, to communicate with iChat, and things like that. And this layer is mostly written in ObjectiveC, with some bits of C. And the user experience layer is definitely written in C, because sometimes in ObjectiveC, this layer contains all the user experience frameworks like Spotlight or Quick Look on Leopard, things like that. But the things to remember here is that there are 2 different kinds of API. They are introspectable APIs like ObjectiveC, which Ruby Cocoa can enter at runtime without any problem. And there are static APIs, which are problematic because they are static and we don't have a way at runtime to deal with them. And I forgot to say one thing. Whoops. On Leopard, we are providing Ruby support for the entire layer. So we definitely want developers to write a full Cocoa application in Ruby. And I'm going to explain now how we did to bridge C APIs on Leopard for Ruby and Python. And we created a new project called Bridge Support. Bridge Support. It's free. It's a BSD license, and you can download the sources on macOS Forge. And the idea is that we are providing metadata description for everything that is static. And the metadata is XML. And we are providing XML annotations for all the static APIs, like, for example, C functions, C structures, C enumerations, C constants, C function pointers, things like that. Everything is described. And we are shipping Leopard with Bridge Support 5 for most of the system framework. We are not covering everything because we didn't have enough time, but it's a great step. And we are also providing a metadata generator, which is available on Leopard. It's usabin gen-rich metadata. You can use it to generate metadata for your own APIs. And it's documented, and the format is also documented. So a few facts about Bridge Support. It's not only for frameworks. You can reach standalone C libraries. For example, the libsystem dilib is covered by Bridge Support. We can use some of the C libc functions in Ruby. It's not only for Ruby. It's completely language agnostic. And PyObc, which is the Python bridge, is also using it. And we did that because we wanted to drive everything from those files and making sure that all the languages can access those features. And if we need to modify something, we only modify it once on the files. And all the bridges are dynamically going to require the metadata files. And it's not only for the bridges, by the way, because Xcode is now using it for auto-completion. Oh, I forgot to show auto-completion. And usabin gen-rich metadata can generate 4 different kinds of files. It can generate bridge metadata files, which are the files that are going to be read at runtime by the bridges. It only contains description for script static APIs, and it can also generate full metadata files. So these files contain everything, all the APIs, including things that could be get dynamically. And Xcode is reading these files, for example. But right now, Xcode is the only client, but we could imagine third-party applications that would like to leverage these metadata. And you can generate an exception template file, which is a bit complicated to discuss now, but the problem is that we cannot determine everything automatically. There are things that need to be done by a human. For example, descriptions about pointers. If you have a function that has a pointer argument, is it in, out, or in-out? There is no way to know that. So if you need to provide special annotations for this kind of commands, you need to write exception files and then give the exception files to the metadata generator in order to generate the final format. And GenBridge metadata can generate a template for you. You just have to change what has to be needed. And can also generate a dynamic library. This is because some things are, it's not possible to describe everything in XML. For example, if you have inline functions in your framework, it's not possible to describe inline functions as XML. So what we do is that we generate a small dynamic library with the same, we expose the inline functions there, and at runtime, the bridges are going to load this dynamic library, and then we'll be able to access all the inline functions of your framework. But it's only required for inline functions for now. And there is a man page, so if you have Leopard, which most of you have, you can do man GenBridge metadata, it's a man page, which was written by someone who knows English, so it's not me. And let's have a look at Foundation. Foundation is a Cocoa framework. It's very critical. It contains all the basic APIs. And if you go inside the framework and go to the resources and then bridge report directory, you will see that there are 3 files. So there is the first file is foundation.bridge report, which is the file that will be read by the bridges. The dilib contains all the inline functions of Foundation. And the full file is big. It's just for Xcode. But now you can see how we distributed the files on the system. And if you have a framework and want to support it, to generate bridge report files, you need to create a bridge report directory in the resources and put the files there. Oh, and I'm going to show you. Oops. Okay, so for this demo, for this demo, I decided to wrap the pcap library. How many people know the libpcap library here? Oh, many people. If you don't know what libpcap is, it's a library to capture packets at runtime. And it's a C API, and it's delivered with macOS 10 by default. So if you look at user include, there are 3 files, and these are headers, and this is the API. And my demo is going to support to be able to use this in Ruby using bridge report. So it's a pure C stuff, it's no ObjectiveC. So I'm going to call the metadata GenBridge metadata. Oops, sorry, the GenBridge metadata tool, and you need to pass some C flags. And so it's going to parse all the headers, generate some small C programs to get all the types, and then it's going to throw out a big, huge XML. Okay. And this is the XML that was returned. And this is, for example, a string constant. It's a sharp-defined string. So it's something that is pre-processed, sorry, and the metadata generator was able to discover it. These are enumerations. And there are lots of enumerations. Oops. And these are functions. Okay. And I'm just going to, as you can see, everything is described as XML elements. I'm wondering if there is a nice example here. No, not really. And this is how you can load manually a rich report file. The first two lines we are going to require the lib_pcap.dilib into Ruby. So what we do here is that we use the dial open routine, which just loads the dynamic library at runtime. It means that all the symbols in lib_pcap will be available in Ruby, but it doesn't do any more stuff. So it just requires the dynamic library. And here we load RubyCocoa, and we just tell RubyCocoa load this file. It's an XML file, and this is where the magic is going to be done. RubyCocoa is going to parse the file very efficiently using libxml CAPI, and it's going to build all the Ruby API, which is described as XML. And you need to know that all the costly operations, like looking for a symbol, is done at demand, so it's not done during parsing, so which is better for performances. And this is the sniff.rb script that I wrote, and I actually ported it from an original C example. And there is nothing really interesting here. These are actually C functions that will be called via RubyCocoa through the bridge. And the nice thing is here we are creating a proc object, and we are going to pass the proc object as the third argument of the pcap loop function. But actually this is a function pointer. So this is very important. RubyCocoa is very smart. When it detects a function pointer and you pass a proc object to it, it's going to create dynamically an assembly closure according to your architecture, if you're Intel or PPC, or 32-bit or 64-bit. And it's going to generate a closure that will call the Ruby proc object, and it's going to pass the closure to the C layer. And this is great. And I can start it. And this is Safari. Can just reload the page. It's working. So these are the packets that are being received. So that's great. And it's okay. Okay, so far everything worked. And now let's talk a little bit about DTrace. Do I have enough time? So I will just do very quickly, I think. DTrace is a new tracing framework that was created by Sun. I'm pretty sure that everybody knows about DTrace. Everybody knows about DTrace? Yeah. And it was put in Laurent. And the idea about DTrace is that by default, so it's a set of probes that are everywhere in the system, in the kernel, but also in the libc, in ObjectiveC, in the Cocoa frameworks, in applications, and also in the scripting languages like Ruby. And by default, these probes have a zero disabled code. So they cost nothing by default, and they are just activated on demand. And it's programmable. So Sun is providing a language called the DTrace language, which is a bit weird to use, and I personally don't like it. And in Laurent, we have a new application called Instruments, and Instruments is a performance tool that leverages DTrace. So you can create your own DTrace instruments. And of course, we are Laurent ships with Ruby DTrace support. So we have DTrace probes in the Ruby interpreter. You can trace Ruby application in production without having to relaunch it or compile it or doing weird things. And you can use also the instruments application to do the same thing. If you want to have the opposite, if you want to have a graphical overview of the results. And these are all the probes that are available in Ruby. So we can, for example, trace when a function is called or returned, when an exception is raised or rescued. Well, every line of Ruby is executed, where the garbage collection starts or ends, when an object is being created or freed. Oh, I have to say that this work was written by Giant. I don't know if there are some Giant employees in the room. No Giant employees. But these guys very rock a lot, and they did all the report. So we just took their work and put it in the report. And here is a very simple script that uses the Ruby DTrace probes. And we just insert events to the function untry and function return probes. The Ruby star means that it will intercept all events from all Ruby process. If you want to target a specific Ruby process, you can put the PID, the process identifier, just instead of the star. And this is the implementation of the tracing. We just printf the line, the file, the line, then the module, and the method. It's very simple. And I'm going to show a quick demo if I have time. No, Passenger. Okay. I'm going to start IRB and in a new tab. Oops, no, it's -L. These are all the probes, all the DTrace probes that are currently available in the system. So we have some stuff in the lib system. We have many probes. If you just want to get the count, I don't know how to say this number, but 21,350 probes. And if you grab for Ruby, oops, okay. These are just the probes that are available on IRB that I just started a few seconds ago. Here, and I'm going to start the example that I just showed on the slide. It's exactly the same. And now in IRB I can, let me detach it. Can I detach? Yeah, that's better. Up. There we go. Up. There's a step that appears, and as you can see, we are calling plus on fixed num, and this is the file which IRB doesn't. This is IRB on this line. The method was IO write object inspect. So you can trace what you want on any process, any Ruby process. And now I'm going to start. I need to shut down this. I'm going to start LampChat. LampChat is the IRC client that I showed in the slide, if you remember. So it's a Ruby Cocoa application, and it's going to connect to. Yeah. Hey guys. and now if I'm going to start instruments. What? Let's start with a blank template, and I'm going to create a new DTrace instrument. And on this resolution, it's a bit hard to use, but here we can select any probe, and there is Ruby. Ta-da! And here we can select all the Ruby probes that I just showed. And let's stick with function and try for the purpose of this demo. Where is the OK button? I don't see. Ah, it's okay. And I'm just going to hey, no. I'm attached to LimeChat. And start recording. And there is some activity. And if I'm going to join RubyLang, which is a huge channel. Boom. And there is sometimes there is a problem. If I can stop. No, it just started again. This was the first run. Ah, there we go. This is the first. No. I don't have enough memory on this machine. No. Yeah. I don't touch it now. Okay. No.
File a bug.
Oh, well, it's okay. Oh, so this was the second try, and oh,
Too impatient.
it's okay now. Okay. And I can do full screen mode. It's better. And we can start examining the data. And you have the file, the line. Sure. And this is the module and the method. And you can see how the module and the method have been called, which is great. We can sort all the system. And a very cool feature is this column. I don't know if you can read. It's the C stack that was captured when the probe was triggered. It's nice because if you are using a version of Ruby with debug support, you can double click and it will write, it will open Xcode and jump into the line where the probe was raised. And for example, if I'm trying to find a Ruby Coco code. Yeah, here. Yeah. It starts with, this is Ruby Coco, and this is Ruby Coco, libffi, appkit. And if I double click it here, it doesn't work. Okay, but normally it should open Xcode and jump into the rbffi dispatch function. It didn't. So, I'm not an expert about DTrace, and I'm pretty sure that you will be able to write much more interesting examples. No. Okay. And I'm pretty sure that you will be able to write better DTrace stuff that I wrote. It's just a demo that prints stuff, and we can do my phone. You can do much better stuff than me. And let's talk about the world domination plans. Thank you. Ruby Coco is a nice project, but it has some limitation. First of all, it's a bridge. So since it's a bridge, you convert objects and exceptions. We need to cache instances so that we don't create the same proxy for multiple proxy for the same object every time. And we have to maintain the object model twice on both Ruby and Objective-C. So it's a bit boring, but it works. It works, but crossing the bridge has a cost. And Ruby Cocoa you can use Ruby Cocoa everywhere. If you have a very complex drawing method that crosses the bridge many times per second, you may find some problem using Ruby Cocoa, even if now we optimize it a lot, especially using DTrace. Ruby Cocoa cannot be used with Objective-C 2.0 garbage collection. It's a limitation now, and this is a very big problem and a very complicated problem to resolve. And we just didn't have the time to fix it. And there are, of course, training problems, which are not our fault, but Ruby 1.8. Ruby 1.8 doesn't have native threads. They are emulated. And Ruby 1.8 is not thread safe. So this is a problem for us. I'm not going to explain because we don't have enough time. And our plan for the future is to use Ruby 1.9, of course, because first, there are no threading problem anymore, because Ruby 1.9 has a native thread, and there is a giant lock that we can use to make sure that we can call the runtime on different threads. And the second point is that we would like to change a little bit Ruby to use Objective-C inside. We would like to rewrite the Ruby model using Objective-C. If we do that, we wouldn't have to create proxy anymore. We wouldn't have to convert objects. We wouldn't have to cache instances. And it would work with the Ruby garbage collector, the Objective-C 2.0 garbage collector. And this is what we are looking now for the future. So, of course, we don't want to start a new Ruby implementation, as Microsoft or Sun did. Hi, John. And we are looking to work together with the Ruby core team to make sure that, because we don't want to fork the project, we don't want to rewrite everything, we want to use Ruby 1.9 and just rewrite the class model. So we are currently discussing with Matt. Not sure if he's here. Hey, Matt. And we are discussing with Matt, and we are both very positive about that. We want to collaborate and make sure that we can work together without forking the project. And everything will be open. Once we have something working, we will open the sources and start receiving contributions. And everything will be open source, of course. And the Objective-C runtime is already open source. And that's all. You can have more information on ruby.macOSforge.org, which is a new website that I created a few months ago.